Good morning, dear students.
Good morning, sir.
Good morning, sir.
Yes.
Good morning, sir.
Yes, good morning. Yes, people are entering slowly. Meanwhile, we shall start today's session. See, as I told you in the last class, we shall go in a slower pace of coverage of syllabus. And in today's class, I'm going to take up something general and which is required for our chemistry lessons generally. These concepts will be there in regular syllabus, but there is no separate emphasis to learn it separately. You would know these things, but not in detail. So I'll take some general concepts of chemistry so that it helps you in learning the lessons as it is required, which as very much basic. Okay, so we shall take up today's class. Okay, so what is exactly we are going to go to? Next week only we'll start the actual chapter. Okay, right. I'll give you some substance. You have to simply identify the substance in terms of a general category. Okay, so a substance given, you should identify it as the nature, identify by its nature. Okay, so for example, I'll give you copper sulfate. So if I give you copper sulfate, so tell me, what is it? It belongs to which category? Copper sulfate. Compound. Okay. Under compound, does it belong to any other substance category? So is it called by any other name, acid, base, or something like that?
Salt.
Okay. It's a salt. So copper sulfate is a salt. Right. So if I take sulfuric acid, so H2SO4 is acid. Okay. So when I say CH3COOH,
Acid.
so what is the name of this?
Acetic.
Acetic acid. Okay. What is the difference between?
It's also called ethanol or something, right?
It's also called ethanol.
I forgot that.
Ethanoic acid. We say?
Yeah. Yes.
Ethanoic.
I meant
good.
that.
Very good. So ethanoic acid is a IUPAC name that you will get in detail when organic chemistry first chapter has been started. Okay. Let's not worry much about IUPAC nomenclatures now itself. Okay. So this is acid. Fine. What is the difference between the first acid and second acid?
Second acid is a weak one, and
It's a weak
the
acid.
first one
Acid is
is
made
a
of
strong acid.
carbon
It has a
hydrogen.
lower pH.
Oh, very nice. Okay. Which one has lower pH?
H2SO.
Okay. Apart from that, apart from being weak and strong, is there any other difference between first one and second one?
So acetic acid is just made up of carbon and hydrogen.
So
It's covalently bonded.
so what a substance which contains only carbon, hydrogen,
Organic compound.
Organic
it is a
Hydrocarbon.
organic acid. It's a organic acid. H2SO4 is a inorganic acid. So can we say like that? Organic acid, inorganic acid. Okay. So then we'll take up yeah.
Sir, it's a base.
Base.
It's a base. What is the name of this?
Milk of magnesium. Magnesium hydroxide.
Pardon me?
Magnesium hydroxide.
Magnesium.
Magnesium hydroxide.
Hydroxide, correct. So then we'll take up. Can anybody give me the name of this? Anybody? What is this compound? What is this compound? Okay, to which class it belongs? Like acid, base, or salt, or whatever.
Acid.
Acid. So, any other? Karthik B in the message is saying that it is base. How about remaining?
So maybe it's acid.
Acid. Why do you think it's an acid?
Because the formula for nitric acid is NH3, and maybe there is some alteration in that, and NH2.
Nitric acid is HNO.
HNO.
NH3 is ammonia.
Oh, sorry.
No problem. No problem. Confusions are general characteristics of learning chemistry. Okay. If you are getting confused in the initial stages, you are learning chemistry. And the same confusions, if it happens at the end of the academic year also, that is the characteristic of a person who is going to lose marks. Okay. So confusions in the beginning, that's good. Confusions again at the end of the syllabus is not. Okay. Amruta says salt, but with a tinge of salt. That is question mark. So, okay. Now, Avani says base. Okay. So, can you people tell me why you consider it as a base? Those people who are considering it as a base. Oh, that was a previous answer. Okay. Sri Raksha says base again. Why do you consider it as a base? People who are telling this compound as a base.
Sir, is it an acid?
Is it because?
As it has hydrogen, when we dissolve it in suitable solution, it will yield hydronium ion, which will result in acidic property.
Okay, so it's an acid.
Yes, sir.
Avani is giving some reason here because of the free electron, which decreases the acidity. So therefore, it is a base. That is the meaning of the thing, Avani. Okay, so we couldn't decide properly about this. Okay, then we shall take another compound, AlCl. Can you tell me what it is?
Salt.
It's a salt.
Yes, sir.
Okay. What was the name?
Ammonium chloride.
Aluminum chloride.
Aluminum chloride.
Okay, so this is acid. This is acid or base?
Base.
In fact, it is neither acid or base. Rather, as you say, it is salt only. But we say it's a acidic salt. Look at that. There is salt which is acidic. Acidic salt is. Okay. Fine. Anyhow, it's a salt is the correct answer. We shall take up further. I'll give you some more examples. Okay. Can you tell me what about this compound? KMNO.
HCl, sir.
Tell me.
Sir, isn't HCl a monobasic acid, sir?
Exactly.
Then how can it form an acidic salt?
Where is HCl?
Here's AlCl. If we combine a HCl plus aluminum, we get AlCl.
Correct.
But HCl is a monobasic acid, no, sir. It shouldn't form an acidic.
No, not that. Okay. HCl when combines with aluminum hydroxide, this is the salt form. Okay.
Okay.
So
Okay.
I'll come to that point. Don't worry. I'll come to that point. Okay. KMNO4.
Potassium permanganate.
That is the name. To which class it belongs? Pranav has given the answer, but why ammonia is a base? Correct, no? He has given the answer CH3NH2. That is the previous compound. Is base just like ammonia, Hmm? So why ammonia is base then? We should answer that, right? Okay,
Yeah,
let
because
me.
when dissolved in water, it acquires the hydrogen plus OH
It can accept a
ions.
proton.
If it can accept hydrogen, it is a base. Huh?
It
So
can
it will,
accept the proton in the hydrogen.
Okay. If it accepts a proton, it's a base. Huh?
no, so that will form a help to produce hydroxide ion.
Yes, sir.
Okay. Okay. Coming to this KMnO4. What is KMnO4?
Acidic.
Salt.
Salt.
It's a salt for sure.
Yes.
It is formed as a result of a combination of acid and base. Okay. Then what about? Let me take a different color. What about this? What is the name of this?
Potassium dichromate.
Dichromate.
Dichromate. What about this now? What kind of substance is this?
Salt.
Salt. Okay. That's fine. Then we have what kind of substance is this?
Chromium oxide.
Chromium oxide. Chromium sesquioxide also we say.
Base.
What kind of substance is that? Similarly,
Base.
salt. Okay. What about magnesium oxide?
Sir, base.
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 Trisha in my IR has given the answer oxidizer. So which is oxidizer, madam? Which substance you have told oxidize?
Sir, the K2Cr2O7.
Okay. Why do you say it is oxidizing?
Sir, it gives oxygen in a chemical reaction.
Okay. Right. Good. Then what about KMnO4? Trisha?
Sir, I don't know.
Okay.
The
Magnesium
KMnO4 is also an oxidizing agent in acidic medium.
Oh, why?
Sir, because it oxidizes when it is in an acidic medium, sir.
Okay. That's a good thing. Okay. So what about magnesium oxide? Somebody were telling.
It's a base.
Oxide.
Added to water, it forms base.
Base.
It's a base. Huh? Okay. Let me
Base,
fix it. So there is no confusion. Okay. So magnesium oxide. Then what about calcium oxide?
Base.
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 Okay. That's fine. Now we'll come to that KMnO4, K2Cr2O7. See, some of the substances we have designated them as acids, some of them as bases, and some of them as salts. Okay. So now the basic question that arises is what is an acid, what is a base, and what is a salt? Correct. So what is an acid? What is an acid?
So when acid is dissolved in water, it gives hydronium ions. When base is dissolved in water, it gives hydroxide ions. And the combination of
And
these are-
acids accept the lone pairs of electrons.
Okay. Oh, very good. So acid accepting lone pair of electron. Have you studied all these things in your school, like accepting lone pair?
No, sir.
Somebody told who told acid accept lone pair of electron?
Sir,
Pramila.
yes.
Okay. Where exactly you have studied that?
Sir, in our school only that taught.
That means
Start in state, but I guess.
in our school only that has taught us. What do you mean?
No, sir. In our school only they had taught us.
Oh, is it? Okay. Very good. Okay. So acid is a substance. At this stage, we shall just keep the concept to the substance which dissociate in water to produce a hydrogen ion or hydronium ion. No problem. Okay. So hydronium ion formula.
H3O plus.
Okay. Dissociates in aqueous medium to produce a H plus ion. But the problem is H plus ion, when it is formed in water, because it is just a proton, very light particle. So it takes the help of solvent water, and water gets that H plus and become H3O plus. Okay, so H plus, all H plus ions whichever is produced in water, they just converted to the H3O plus. So the substance which dissociates to produce a hydrogen ion or a hydronium ion can be an acid. So that's correct. pH less than 7, that's correct. Okay. Anandavan. Okay. So then a base is a substance. We'll take a base. A base is a substance. What do we say? A base is a substance which dissociates in aqueous medium to produce
Hydroxide.
a hydroxyl ion. Okay, it just remains as OH minus ion, hydroxyl. So based on that, if you look back, yes, we have MgOH as a base, correct? And you can give sodium hydroxide as a base. Some more examples to take as a base, or potassium hydroxide as a base. You can see they all contain OH minus ion. Upon dissociation, they produce OH minus ion. So, but why do we call this ammonia NH3 and methylamine CH3NH2 is methylamine? Both are bases actually. Okay. Somebody gave me in between the correct answer. So why do we consider these substances do not contain OH minus ion, but still they are considered as bases? Now, if you don't know the answer, that's fine. We are going to study much about these acids and bases in detail in our syllabus, not well. Okay. So methylamine, ammonia are bases. Just for time being, I'll give one sentence reason, because they have this electron pair on nitrogen atom in the molecule. That electron pair is unshared. It is not involved in bond formation. The pair of electron which is not involved in bond formation is called by some name. What is that?
Lone pair.
Lone pair.
Lone
So LONE, lone pair of electron. So that lone pair of electron, which is unshared pair of electron present on an atom, is called lone pair. That lone pair can be donated. Lone pair donor is also called a base. Lone pair donor is also called a base. Okay. Again, we are going to take these concepts much in detail little later. We'll just restrict our discussion as an introduction class today to H plus and OH minus ion. Okay. So fine. So the base is a substance which can dissociate in water to produce a OH minus ion is what is the definition of. Okay. Then what is a salt? What is a salt? What is the definition of a salt? Anybody?
Side product formed when acids and base react.
Okay. Salt is a substance which is a product of reaction of acid and base. If acid react with a base, it gives salt and water. What is that reaction called?
Neutralization.
Neutralization.
Okay. So therefore, a salt is a substance which can be the product of neutralization of acid with a base. Now, how a salt is formed is the thing that you got the answer now. How a salt is formed? Salt is formed as a product when acid is neutralized by a base. But what is a salt if they ask you directly? Again, you will say the same thing. How a salt is formed? A salt is formed by the neutralization reaction of acid and base. That's right. But what is a salt by itself? Anybody? What is a salt by itself?
So it's an electrovalent compound.
Electrovalent compound means, is it covalent compound or ionic compound?
Ionic compound.
Ionic.
Okay. Sodium hydroxide. Is it an ionic compound?
Yes, sir.
Then can we call it as a base, salt or base?
It's a base.
It's a base.
Sodium
So
hydroxide.
the definition such as it's an electrovalent compound doesn't hold. Okay. So because HCl is also ionizing, sodium hydroxide is ionizing, we can't call them as salt. So salt must be defined in some other way. Can anybody give me the definition?
Salt when dissolved in suitable solvent yields ion with other than hydroxyl and hydronium ion.
See, he is very witty. He has found out the example from all cases, since it doesn't contain H plus and OH minus. He is saying this salt is a substance which dissociates to produce an ion other than H plus and OH minus. So can I call K2Cr2O7 as a salt? Pranav? Because it dissociates to produce an ion which is other than H plus and OH minus. That's what Vedesha. See what you have written. No, when acid and base react with each other, the product which is formed with water is salt. Right? So how a salt is formed? That is the correct answer. How a salt is formed? By the neutralizer. But what is a salt? What is a salt? I didn't get the definition. Consists of positive ion. Anything that consists of positive ion is a salt. Sodium hydroxide also contains positive ion, Na+. Can it be salt? Can we call it as a salt? Come on. Anybody with different answers? See, we have heard of salt, but we don't know the definition of salt. Where is Sarthaka? Come on, you need to answer. So you don't know what is the definition of salt then. Okay. Okay. So let's write the reaction itself of the formation of this salt. Okay. So when, as I said, acid react with a base, but I'm not giving the definition. I'm just writing the reaction of formation of salt. So acid plus base giving rise to aqua plus taste. We say. Acid plus base, aqua plus taste. What is aqua? Water. Taste, salt is taste. Simply just like that. Acid plus base, aqua plus taste. Okay. Electrically neutral substance. Electrically neutral substance. Can it be the definition of salt? Apti? Any substance is electrically neutral for that matter. Any substance that exists in the nature, be it acid, base, oxidizing agent, reducing agent, any substance that exists in the nature should be neutral. Total positive must be balancing total negative. So always like that. Okay. So that's that. So anyhow, so acid plus base, it gives salt and water. Okay. If I take
ionic compounds formed from the reaction of acid and base.
You have altered the definition. The same definition which will have to be given to the question how a salt is formed. It is more or less the same, but slightly altered to sound like a definition. Witty. Okay. So we'll take up now further. Now again, salt is a compound consisting of cation and anion. Cannot be the definition because even acids and bases contain cation and anion. Okay. No, that's not the case. Okay. Now listen up. I'll give the definition. Pay attention. Okay. Fine. I have this sodium chloride with me. Okay, I have this sodium chloride with me. Sodium chloride is a salt. So tell me, this salt is obtained from which acid and which base?
NaOH and HCl.
NaOH and HCl.
Now, NaCl, which is formed as a result of neutralization of the acid HCl and the base NaOH, contains its ions. Which is the ion present in NaCl from NaOH?
Sodium ion.
Sodium ion. Na plus ion is from the base. Which is the ion of NaCl present from HCl?
Chloride ion. Chloride ion.
Okay, chloride. So now we call these ions, since they are from respective acids and bases, by their name itself, name of origin. Okay, see, we use the name radical. A radical is a species which can be a cation or anion or even a free radical. A free radical would contain a odd electron, okay, unshared electron. So a radical is a word which can specify any reactive intermediate. It may be anion, cation, or a free radical. Okay. So now Na plus is a cation, which is from sodium hydroxide. Therefore, this Na plus is referred by the name basic radical. Basic radical. Cl minus is referred by the name, therefore, it is from acid. So acid radical. Okay. So now can anybody tell me what is a salt? A salt should always contain what?
A positive ion from a base and negative ion from an acid.
A positive ion from the base is called basic radical. The negative ion from the acid is called acid radical. So the substance which contains an acid radical, a substance, one second, which contains an acid radical and a basic radical is called a salt. Is called a substance which contain acid radical and a basic radical is called a salt. So yes, we shall take up some of the examples. Now you just need to identify which is the acid radical and which is the basic radical. Avani, definitely that is also correct. There are different definitions for acids and bases. The one which accepts the proton is also a base. As I told you, today is my introduction class for acids and bases. Later, we are going to take up a chapter in which these things are dealt in detail, which are all acids. Is it only the substance which dissociate to produce a proton is acid? No. Is it only the substance which dissociate in water to produce OH minus ion, hydroxyl ion, is a base? No. There are many other. Like for example, we have taken just now ammonia. So NH3 donates a lone pair of electron. At the same time, it accepts a H plus ion, hydrogen. So either a proton acceptor or lone pair donor is a base. Don't worry about it. At this stage, just remember or understand what is being taught. Okay. We are going to take all different combinations. It's just not only H plus donor is acid or OH minus ion donor is a base. There are other class of compounds also which can be called as acids and bases. Okay, don't worry. Our emphasis will be on salts and writing the formula, these kind of things as basic today. Okay, nothing about that. Okay. So as you said, there are other substances also which can be called by acid and base. Okay, we'll take up first. So now I'm going to give you some names of salts. What you need to do, You just need to give which is acid radical there, which is basic radical present there. Okay, so fine. I'll take ferric chloride. Okay, is ferric chloride a salt first of all?
Yes, sir.
Yes, sir.
Yes. Okay, which is the basic radical there?
Fe.
Fe. What is the
Fe+.
charge on Fe by any chance?
3+.
Fe3 plus. Why Fe3 plus? Because chloride we know. Chloride is -1. How many chloride are there? 3. So -1 into 3, -3. So FeCl3. So Cl3 are there. 3 negative ion. To balance that -3, iron must have to have +3. So that entire compound will be neutral. So as I told you, any compound that exists in the nature will be neutral. Total positive must have been balanced by total negative. So this is ferric chloride, we say. So ferric chloride is basic radical. So why do we call ferric chloride as basic radical? One is it is cation. It comes from the base. Which is the base that will produce ferric ion?
FeOH thrice.
Very good. What is the name of that?
Hydroxide.
Ferric hydroxide. Okay. So FeOH thrice. Okay. And which is the acid that produces Cl minus? We know that. That is
HCl.
HCl. Okay. So FeOH thrice plus 3 HCl would give ferric chloride. So therefore, this is Fe is basic radical. B radical I have written. Cl is acid radical. Right. Okay. We shall proceed further. I'll give one more example. So let's take.
Sir, are we allowed to write like above Cl minus 3 or should we write 3 Cl minus?
That is generally to avoid confusion. There is no standard rule for that. For example, if it is nitride ion, N minus 3 or N3 minus. No problem in both the ways. But better is N3 minus for the reason that it sounds a correct ion. Okay. Or else there is azide ion also, N3 minus. What do you write now? Therefore, there is plus and minus in both the symbols, but there is no standard rule that we need to write in this manner only. It is followed by convention. That's all. No issue. Okay, you can write. Okay. Now, can you people tell me what is aluminum sulfate?
Al2SO4 thrice.
Very good. So aluminum sulfate, Al2SO4 thrice. Okay. Now, is it a salt?
Yes, sir.
Yes. Which is the basic radical?
Aluminium.
What is the charge?
3+.
3+. Which is the substance that produces aluminum ion?
Aluminium
hydroxide.
Aluminum hydroxide. Okay. So very good. When I take up this, AlOH thrice. Aluminum hydroxide is the base. And which is the acid here?
Sulfuric acid.
H2SO4. Okay. So this is Al3 plus and sulfate has SO4 2 minus. So thus the salt formed is aluminum sulfate. So therefore it contains the basic radical here from base and sulfate from acid. Therefore it is acid. Now we have very much clearly understood. I'm going to give you some sentences. You have to answer, or if the sentence is right, you have to say right. If it is wrong, you have to say wrong. Okay. Now, a substance which contains an acid radical and a basic radical is an acid, right or wrong?
Salt.
It is salt. Okay. A substance which dissociates in water to produce OH minus ion is a acid.
No salt.
Base. It is a base. Substance which dissociate in water to produce OH minus ion is a base. Substance which dissociate in water to produce a hydronium ion.
Acid.
A produce a H plus ion?
Acid.
Acid. Okay. Sodium hydroxide is a base because it produces H plus ion.
OH minus.
Sulfuric acid is a base because it produces H plus ion. Acid because it produces H plus ion. Okay. So that's why. So a salt is a substance which contains acid radical and basic radical. And acid radical is always negative. Basic radical is always positive. Am I right or wrong?
Yes. Yes, sir.
Acid radical is always negative. Basic radical is always positive. Am I right or wrong?
Yes, sir, you're right.
So basic radical, common sense, comes from base. Acid radical comes from acid. It is always okay. So a salt is formed by neutralization. Neutralization, look at the word, the acidic nature and the basic nature, when they combine, both gets nullified, neutralized. So that's why it is very aptly called neutralization. Both after the reaction, there is no acidic, there is no basic, the salt does form. By and large, it is neutral, but some compounds, some salts will be acidic, some compounds or salts will be thus formed by neutralization will also be basic. As I've written here, you can see acidic salt. I've written aluminum chloride is an acidic salt. Okay. Now, we didn't fill some of the gaps here. We have understood what is acid, what is base and all. Now, in the same lines, can you tell me acetic acid is acid for the reason that? What is the reason?
Dissociates H plus ion in aqueous medium.
Correct. It gives CH3COO minus and H plus. What is CH3COO minus? Acetate ions. Acetic acid is acetate ion. CH3COO minus and H plus. So there is H plus. So acetic acid is therefore acid, and of course it contains carbon, hydrogen. So therefore it should be considered as organic acid. Okay. And here, what is I'll put a star here for the reason that methylamine is out of the concept of OH minus ion. Okay, it donates a lone pair, or you can say it accepts a H plus. So we are going to take up later in detail all these concepts, variety of substances which can be classified as acid and bases on different concepts. Okay, so not to worry. So we'll come back to this KMnO4 and potassium dichromate. KMnO4 is an oxidizing agent. What about potassium dichromate? Is also an oxidizing. Okay. For example, you can take lithium aluminum hydride. Another example, I'll just give. Lithium aluminum hydride is a reducing agent. Reducing agent. Okay. And even you can take ferrous sulfate, for example. Ferrous sulfate is a salt. Of course, it is a salt. It comes from ferrous hydroxide and sulfuric acid, but also often found in the reactions acting as reducing. Okay, and this chromic oxide, okay, that is chromium sesqui oxide, is the one which is to be dealt with little cautiousness, for the reason that if you think it is oxidizing agent, it will be behaving as reducing agent. The moment if you think it is reducing agent, it will show some of the acidic behavior also, or oxidizing behavior also. So can you tell me the substances which can also act as acid, which can be just behave as bases? Can be
Ferric oxide.
Amphoteric substances. Which can behave both as acid and base. Okay, so just know about all these examples. We have these different kinds of examples like acid, base, salt, oxidizing, reducing agent and all. By definition, just to quench the interest, a reducing agent is what? Generally, which substance could be called as reducing agent?
It reduces the oxides to its metal form. It removes the oxygen from the
Okay.
metal.
Anything that reduces substance into its metal.
Not it's metal. I meant it takes oxygen. It gets oxidized. So
It gets
it's less if it's metal or whatever.
It gets oxidized. Reducing agent gets oxidized. An oxidizing agent gets reduced. Okay, so vice versa. This definition will be highly confusing. Okay, a reducing agent gets oxidized. An oxidizing agent gets reduced. So anyhow, we will. There is little more time in some other chapter. We are going to consider this oxidizing, reducing, and all those things to give minimum possible confusion or statement with the minimum possible confusion. I would just say this like this. A reducing agent is one which accepts electron. I'm sorry, reducing agent. No, a reducing agent is one which donates electron. Okay. Okay. An oxidizing agent is one which accepts electron. Okay. So with this, there is no minimum, there is no confusion, or rather, concepts will be much more clear. Okay. Any substance in the course of reaction, if it donates electron to another, it can be called as reducing agent. Any substance which accepts electron from another can be called as an oxidizing agent. And then an amphoteric substance can therefore donate and accept both. Okay. So fine. We'll get back to our formula. Okay. Now what we'll do, we will identify different acid radicals and different basic radicals and try to write the formula of the salt that would be formed from that. Okay. So that's fine. Okay. We'll take some of the acid radicals. We'll take. Okay, some of the acid radicals. Yes. Common acid radicals, let's list out. Okay, so like for example, Cl minus. What is the name of Cl minus? Chloride. I'm sorry. Chloride radicals. This is
Bromide.
Okay, so then what is this SO42 minus? Sulfate. What is SO32 minus?
Sulfide.
Good. Sulfide. Should remember the names and the formula, everything. Okay, so sulfide. So then comes what is S2 minus? Look at
Sulfide.
Sulfide.
Very good. Sulfide, PHID, sulfide. Okay. So what is NO3 minus?
Nitrate.
Nitrate. Okay. Similarly, what is NO2 minus?
Nitrite.
Nitrite.
What is N3 minus?
Nitrite.
Nitrite.
Now look at that. There is little difference. Okay. So if you doesn't practice and revise well, the differences cannot be clearly understood and remembered. Okay. So revision is only the required tool to just minimize the confusion and remember it clearly. Okay. Nitrate, nitrite, nitride, something like that. Okay. So then what is this C2O4 2 minus? Anybody?
Sir, oxalate.
Very good. Oxalate. What the definition has been given by Sarthaka. Okay. Oxidizer loses electron, reducing gains electron. A reducing agent is one which reduces the other. I am a lecturer because I teach. My name is what I do. Okay, Sarthaka. An oxidizer oxidizes the other. In order to oxidize the other, the substance has to be oxidized, means it has to lose electron, that substance. So this guy who is called as reducing agent should accept electron. So if I accept electron, I am an oxidizing agent. If I am going to accept electron, I am going to oxidize some other substance. So that's why a substance which accepts electron undergo reduction, one which undergo reduction is an oxidizing agent. Okay, don't worry, we'll take a little more in detail later in a chapter. There is a chapter itself reserved for this discussion. Similarly, a reducing agent. Why the substance is called reducing agent? Because that substance is reducing some other substance. Okay, if I am called as reducing agent, I have to reduce somebody. Reduction means adding electron to that substance. So if I am a reducing agent, I am going to give electron to somebody. So that means I need to lose electron. The one which loses electron is a reducing agent, which donates electron is a reducing agent. Otherwise, which accepts electron is a oxidizer. Okay, don't worry. We'll take up that. I think Sarthaka, is that okay?
Yes, sir.
Okay. So oxalate is C2O4 2-. So we'll take some other ions like, what is this? Cr2O7 2-. Anybody?
Dichromate.
Dichromate. Cr O4 2-.
Chromate.
Very good. Chromate. Okay. Then we have MnO4-.
Permanganate.
Permanganate.
We have MnO4 2-. We say manganate. Okay, so these are all some of the common acid radicals which we come across. So similarly, we shall write some of the basic radicals and try to give some formula of the salts. Okay, so basic radicals are all cations simply. Okay, it can be Na plus. There is no characteristic ending. So for negative ion, it is IDE. Okay, so whereas positive ion, simply sodium ion, we say, that's all. So I'll therefore list out separately, simply like this: potassium ion. Similarly, magnesium ion, we have aluminum ion, 3+. Okay, so we have calcium. These are all basic radicals, right? So list of acid radicals and basic radical help us in writing the formula of the salt. That's why. Okay, so similarly, you have ferrous ion, ferric ion, cuprous, cupric, Cu2 plus Cu plus 1. Between Cu2 plus Cu plus 1, which is cuprous.
Cu plus is cuprous.
Lower oxidation state ends with OUS, cuprous. Higher oxidation state of ion will be ending with IC, cupric. Similarly, Fe3 plus Fe2 plus. Higher oxidation state is Fe3 plus ferric. Lower oxidation state is ferrous. Okay, so if you want, I can write the names. Ferrous, ferric, cupric, cuprous. Okay, no issue. What is the next stage is, I'm going to give you the formula with whatever the formula I'm going to give, you have to give me the name of that. And if I give name, you have to give me the formula, vice versa. That's all. Okay. So we shall take up that. Give me the formula of ferric bromide.
FeBr3.
FeBr3. Now, for those who have a little confusion in writing the formula, say ferric ion, you know, just now I have written ferric ion means Fe3 plus. Bromide is Br minus. So always you should do crisscross. That means this -1 should come as a subscript to iron. This charge on iron should come as a subscript to Br. So therefore, it will become Fe1 Br thrice. Generally, 1 will not write. Okay, that's all. Okay. So we'll take up ferrous sulfate.
FeSO4.
SO4.
Okay. Ferric sulfate.
Fe2SO4 thrice.
P2 SO4 thrice.
Again, if you have doubt, for those who have doubt, I'll just explain this. Fe, ferric means Fe3 plus charge. Sulfate is overall, it carries 2 minus, crisscross. Right here, and this 2 minus should be written as a subscript. So therefore, this formula becomes Fe should be given 2 and SO4 should be given 4. So since it is a complex ion, put a bracket and write thrice. Fe to SO4 thrice. Okay, so that overall charge will be balanced. Total positive charge must always be equal to total negative charge. Fe is 3 plus into 2, if you multiply it becomes plus 6. SO4 2 minus into 3 becomes minus 6. So it is overall balanced. So ferrous sulfate, ferric sulfate. That's fine. Next we'll take a give me the formula of calcium oxalate.
CaC2O4.
CaC2O4. Calcium is 2 plus, C2O4 is 2 minus. So overall it's balanced. No need to have any different substance. Okay, so calcium oxalate. That's fine. So next comes silver chromate.
AgCrO4.
AgCrO4.
Ag2CrO4.
Sir,
So
it can also be Ag2CrO4.
it is only Ag2. Also, there is nothing other about. Okay, so Ag plus Cr2O4 2 minus. Right, 2 here, 1 there. So it should be Ag2CrO4. Silver chromate. Okay, so silver chromate.
Silver can also be 2 plus, sir.
No, silver can't be 2.
Oh,
silver is only one oxidation state. It exists in +1 oxidation. Can never be any other oxidation state. Is that okay? Okay. So now we'll take up further. I'll give you the formula of the salt. You have to give me the name. Okay. We'll take Ag2S.
Silver sulfide.
Ferric sulfide.
Okay.
Sodium oxide.
Sodium oxalate.
Sodium acetate.
Sodium acetate.
Okay, what is one thing importantly you observe in all these salts and this last one example? What is important observation?
Sir, usually the most electronegative element will be written in the end, and the lesser electronegative will be written in the beginning.
For which one?
For most of the compounds written here,
but in case of what is this therefore?
Here Na is more electropositive than CS3CO.
That means anion cation. We can simply say anion. No problem. Okay. So in all the cases, cation will be written first. In the last case, anion is written first. So in which case generally we do like that? Anybody?
Organic compound.
Organic salts. Okay. So silver sulfide. This is ferric sulfide, sodium oxalate, and this is sodium acetate. Sodium acetate. Okay. So organic salts. So which is the acid radical in sodium acetate?
Acetate radical.
Acetate ion. Acetate ion is the acid. Sodium ion, Na plus ion is the basic radical, because acetate ion comes from acetic acid. Sodium ion comes from sodium hydroxide. So therefore, acid radical, basic radical containing substance will be salt. Fine. So this is the concept. Right. We shall take write the formula of calcium formate. Okay. Similarly, write the formula of calcium benzoate. Potassium phenate. Okay. I want the formula. You can either type it in the chat box. In fact, I was trying to make some kind of pause among the students, and that has been obtained now. Little pause. I couldn't observe any pause. That's a good thing, actually. Now there is little pause. I'll give one. Disodium salicylate. Oh, yes, I'm getting the answers in the chat box. HCO2 twice Ca. Very good. Amruta Varshini. It has to be anion, right? HCOOH is formic acid. It has to be formate ion. Okay. Okay. Rn calcium formate. Yeah. As I told you, being organic salt, the anion first and then the cation. Organic salts. Sri Raksha. anion first and then cation. Calcium benzoate. Okay. C6, C7. Correct. Right. Very good, very good. Yes, some of you have given correct answers, but see to it that you write anion first and then cation. Whatever examples which I have given here now, are they all organic salts? Are they all organic salts? Or inorganic salts also? Organic salts and inorganic salts. If they are obtained from organic acids, can be called as organic salts. Fine. Exactly. C6H5, COO twice. Ca. Correct. Right. Okay. Let me give the answer for all this. Okay. So give me a little time. 1 second. Look at this. Yeah. Formate is HCOO is formate ion. Calcium Ca2+ ion. Am I right? What you have to do? Crisscross. You have to write the 2 for as a substitute for formate ion and 1 as a substitute for calcium. So what should I do now? Therefore, I'll just write like this. HCOO twice Ca. Okay. Now calcium benzoate. Now, what is benzoate? The ion which is from benzoic acid. Okay. Let me write here. C6H5 COOH. This is benzoic acid. Okay. So when it dissociates, it gives C6H5 COO minus benzoate ion. Okay. So then calcium benzoate would be what? Therefore, C6H5 COO Ca. So write this one 2 times. Ca2+ and Ca. And some of you have written like this. C7H5O2 twice. No problem. No problem. Okay. But always write the formula of the anion properly like that, so that it is familiar for everybody, so that easily it can be read. Potassium phenate, I didn't get the answer. Any potassium phenate? Okay. Phenate is the anion from phenol. Can anybody give me the formula of phenol? What is phenol? This is benzene, right? Attach one OH group.
Sir, C6O.
C6H5OH, correct. This is phenol. If it dissociates, it gives C6H5O minus. This is phenate ion. Or phenoxide also they say. Phenate or phenoxide. So this is phenol and that is phenate. Okay, this is benzoic acid. I didn't write the name. Right? Now, I think it is easy to write the formula now. Can anybody give me the formula now?
C6H5OK.
Exactly. Okay. C6H5OK. Like, so this is potassium phenate. Next is disodium salicylate. Anybody? Sri Raksha, okay. Anybody? Disodium salicylate? No idea. Okay. First of all, tell me which is the anion here? Which is the anion?
Salicylate.
Salicylate. Salicylate anion comes from which acid? Any idea?
Salicylic acid.
Saccharic acid. Huh? I didn't get your answer. Which acid? It is
Salicylic acid.
salicylic acid. Salicylic acid. Okay, salicylic acid. How is that exactly? See, look at this. This is if I write a COOH here. This is benzoic acid. If I write one OH also at this position, this is salicylic acid. Salicylic acid. And it can dissociate to produce a salicylate dianion like this. Okay. In fact, COOH donates H plus first. And if there is one more base, then this OH also donates H plus. So this is dianion. For example, if you take only OH as the group remaining undissociated, then it becomes simply salicylate ion. Okay, but since there are two negative ions found by the dissociation of both the groups, it is salicylate dianion. Now it is disodium salicylate. What do you need to do? You need to attach sodium ion to both the negative part. Okay, so let me write this. Na ONA like this. So therefore, this is nothing but disodium salicylate. Disodium salicylate. Like. So these are all organic salts. Right. Yes, it is salicylic acid, correct. Are you writing? Let me know if it is complete.
1 minute, sir.
Yeah, you can take no issue. So in our class today, we have understood how to write the formula. While writing the formula of the salt, taking care of balancing the overall negative and positive charge, and writing the subscripts appropriately, these kind of things have to be taken care. And if it is an organic salt, the acid radical, that is negative ion first, and then the basic radical, positive ion. For all the inorganic salts, the cation first, and then the anion. For most of the salts, it is organic, the reverse. Hope all of you written remaining formulas also. If not written, you can ask me for scrolling down.
Sir, what's the final formula for disodium salicylate?
I've written over here in white. I'll just sum. This one. What do you mean by that? You take salicylic acid, react with sodium hydroxide, it forms disodium salicylate. Is that complete now?
Yes, sir.
Okay. Now make it fast. At the end, I have just 2 minutes remaining. You people have to answer my questions now. Okay. Make it fast. C2O4 2 minus, which ion?
Oxalate.
Oxalate. SO3 2 minus.
Sulfide.
N3 minus above.
Nitride.
Nitride. Now, what is the formula that is K2C2O4?
Potassium oxalate.
Potassium oxalate. Then what is Ag2SO3?
Silver
sulfide.
Silver sulfide. Then what is FeS?
Iron sulfide.
Iron sulfide is fine. It is called iron sulfide, no problem. It can be ferrous sulfide in particular. Then what is the formula of copper sulfate? Okay. Substance which dissociate in acid in water to produce H plus ion is a
Acid.
dissociate in water to produce OH minus ion is a substance which contain an acid radical and a basic radical. A basic radical is always negative ion. An acid radical is always negative ion.
True. Yes.
A basic radical comes from always acid.
No.
Base.
Okay, a base. Okay. So this is about the thing. Okay. So rest will take up. So probably we'll meet in the next week. We'll start up with the actual syllabus. Okay. So fine. Till then, take care. Be safe. Meet you in the next class. Thank you.
Thank you, sir.
Thank you.
Thank you,
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you. Yes, I'm going to end the meeting.